right, so we've got a lot to cover in this video. We're going to start with actually using our Pi Pico Ws and our half breadboards and using actual hardware. I'm going to show you how to download this program here called Thonny. I'm going to show you how to connect your breadboard up. I'm going to show you how to load MicroPython on it the first time, because when you get a new Pi Pico W or Pi Pico, it does not actually have the software MicroPython on it yet. So I'm going to show you how to do that. I'm going to show you how to get MicroPython, the REPL, opened, so you're actually running code on your Pi Pico W. We're going to flash the onboard LED just like we've done before, and then we're going to wire up an LED, learn how to select a resistor value for it so we don't burn out that LED, and then get that flashing as well. So that will be the extent of this video. So it's a lot to cover, so let's get going. So first things first, in order to be able to connect your, let me switch over here so you can see a little bit better. To be able to connect your Pi Pico and your, let me turn off portrait mode so you can see well. There we go. To be able to connect up your Pi Pico W and your breadboard, we're going to need a cable. And the cable you're going to need is a micro USB cable. It is the one that has this flat side here, and it's like a Kindle for a Kindle. So you're going to be using a micro USB cable. Obviously the other end is a USB plug. So if your computer doesn't have a USB port, you're also going to need a USB-C to USB adapter so that you can plug that into your computer. So looking at our this web page here, we're going to need to go to thonny.org. So it's thonny.org. Pull up that website. Depending on whether you have a Windows or a Mac, you'll download the appropriate version. It says it's got two options here. You're going to go with the 64-bit version with Python 3.10, and for Mac, you're going to take the installer for Python 3.10. Let that download, click through to install it. If it asks you for a configuration for Raspberry Pi versus standard mode, do standard configuration. When you do that, it should come up, and this is what it should look like. This is what Thonny looks like. And when you come in here, you can see that you've got local Python 3. And what this is doing is it's running Python on your computer, not the microcontroller, because we haven't connected the microcontroller yet. And you can see I can do the whole hello world thing here, and this is running regular Python on your computer. But what we want to do is we want to get your Pi Pico connected. So I'm going to show you how you're going to do that. So jumping back over here to my webcam, we need to put the Pi Pico on the breadboard just like we did in that last video in Wakwi, I should say. I think it's pronounced Wakwi, but there's variations online. So what I do is I line up all of my pins so that it's just like what we saw on the video, but I haven't pushed it in all the way yet. And the reason is I don't want to, it's really hard to get these in and out of these breadboards. So I'm going to just take it once I've made sure that I've got my USB connection at the edge of my board, and I've got 2 pins on either side of my board, just like we did online. Then I'm just going to take it and press that in firmly, and now I've got my board connected. Okay. First time that you're going to connect it, we need to load MicroPython onto this board. And the way that we're going to do that is we need to press that button that you see right there. This is the boot select button, and it actually even says boot select right there above it, boot select. And this puts it in a mode where we can load MicroPython on it. So the way we do it is we press and hold the button, and then we insert the cable, and When I do that, I should be able to come down here. Let me, show you my desktop again. I should be able to come down here, and at the bottom of the screen there, you can see where we had local Python 3. Now we have install MicroPython. If you didn't press the button down, you may see it say something different. So just unplug it, press the button, and insert the cable. Be aware if nothing comes up and you're sure that the cable's plugged into your computer, likely the problem is not all of these cables are data cables. Some of them are just for power, for charging, headphones, and things like that. You need to try a different micro USB cable and it will work, okay? So you press and hold the button, and then we'll click Install MicroPython. Now, most of our devices, assuming that you have a shiny metal box there, shiny rectangular piece of metal there, then it's a Pi Pico W. If that shiny piece of metal is missing, then it is a Pi Pico. And in my class, I have a couple of Pi Picos that I've passed around for people to use. So we need to choose the variant. So if yours has that rectangular box, we're going to do Pico W, and then we're going to click Install. It's going to download from the internet there and install MicroPython. So it's downloaded it. Now it's copying it over to the device. Almost finished copying. And now I've got the latest version of MicroPython installed on my device. So I can click Close. Now I'm going to come down here again and see where it says Local Python 3. Now I can click on MicroPython Raspberry Pi Pico. And now look, it says MicroPython running on the Raspberry Pi Pico W. So now whenever I click or type print hello world, it's running that in the REPL that is actually on this Pi Pico W. So let's write some code. I'm going to come up into this window and I'm going to click open, and I'm going to open a file that is on my Pi Pico. Now, actually no, I won't do that. I'm going to click cancel. I'm going to open a new file because for you, you likely don't have a file. So we're going to do a brand new file, and we're going to do from machine import pin, just like we've done before, and from time import sleep, and it has autocomplete just like we've seen before. I'm going to create my LED object from my pin class and create an instance of my pin, and I'm going to do pin special LED. I'm going to flash that onboard LED, and then it's going to be an output pin, and then I'm just going to see if I can turn it on. So I'm going to do LED.on with the parentheses because I'm actually going to run that method. All right, so I'm going to click save, and I'm going to save it to the Pi Pico, and I'm going to call it main.py. Now, you likely might not have a file there called main.py, so you're going to type in this box right here, main.py. The .py means it's a Python file, and main is a special file. The main file, main.py file, when we save any of our code as main.py, it tells that the Pi Pico is always looking for a file called main.py. If it sees a main.py file, it will always run the code in that file. So what that means is that we can unplug our cable after we save it. We can plug it just into a power connection, and it's going to run our code. So if it says turn on the LED, disconnected from our computer, it will always run that main.py file and turn on the LED. So I'm going to click OK. I already have one, so I'm going to say yes, you can overwrite that. And when I do that, all right, So now I'm going to tell it to run the code. So I'm going to click on this little green play button, and it should run the code. And you can see that, I'll come up here so it's large, you can see that it did in fact run the code and turn on my onboard LED. All right, so we've successfully been able to turn on the onboard LED. Now we want to wire up, just like we did in that last video, we want to wire up an LED on our board. And in your kits, I've given you some of these LEDs. So I've given you some of these LEDs. And on these LEDs, there is a short and a long leg. The short leg is the negative lead. It is the cathode. The long leg is the anode. So you need to pay attention to the long leg and know how to connect it up. So for me, I'm going to turn it so that my short leg is on column 30, on the outside edge of my board, okay? So this outside edge is my negative. It's the short leg. All right, so in your bins, you have some of these wires here. So what I'm going to do is I'm going to plug that column 30 into my negative rail, any of the pins in my negative rail. So what I've done is I've connected that outside row, that column 30, and I've plugged it from here over into my negative rail. Now, before we go any further, we need to know that this LED has a forward voltage of I've got it written down here, 1.71 volts. So let me jump over here. It has a forward voltage of 1.71 volts is my red LED forward voltage. What that means is that it takes 1.71 volts for my LED to turn on. I need to limit how much current is like electricity, the flow of water through a pipe. I need to limit how much current flows through my LED to about 10 milliamps. If I let much more than about 10 milliamps of current flow through my LED is going to have a shorter lifespan or it's going to burn out. So what I need to do is I need to put a resistor in series with my LED. And this right here is what a resistor looks like. We've seen them on some of the circuit boards, and they've got colored bands that tell you what the resistance is of the resistor. So we need to first figure out how to calculate what resistance we need for our LED, for our resistor to protect our LED. So the way we do that is with something called Ohm's law. Ohm's law is just a formula that we can use to calculate resistor values. And the formula is volts are equal to current times resistance. So V is volts, I is current. So this is voltage, the unit is volts. Current, the unit is amps. And resistance, the unit is ohms. Or you'll sometimes see it written with the Greek letter omega, so ohms. So what we need to do is we need to do a calculation so that we can figure out what resistance will give us around 1.7 volts and only 10 milliamps for our circuit. So the first thing you need to know is that the Pi Pico's pin is always going to give us 3.3 volts, but we only want 1.71 volts. So what we're going to do is we're going to say minus 1.71 volts, and I'm going to do some quick math here. 3.3 minus 1.7, that gives us let's do 1.59 volts. So we need a resistor that is going to drop our voltage by 1.59 volts. That is, we need the resistor itself to use 1.59 volts. So that's where we can use Ohm's law right here. So we're going to say the resistor is going to need to have a voltage drop of 1.59 volts. We want it to have a current of 10 milliamps. Now, we need to write this in amps. So 1 milliamp is equal to 0.001. It's 1,000th of an amp. 1,000th of an amp. So if I have 10 milliamps, that would be 0.01. So 0.01 amps times my resistance R. So if I want to isolate my resistance, I just divide both sides by 0.01, 0.01. This cancels out, and I am left with 1.59 divided by 0.01, or 159 ohms. So my resistor needs to be 159 ohms, or ohms. I usually write out ohms personally. All right, so I have a 150 ohm resistor here, and the way that you can tell what the resistor value is by looking at the bands that are on this resistor. And I realize it's going to be too hard for you to see, but I can tell you the colors of these bands. The colors of these bands are brown, green, black, black. So looking at brown, green, black, black, and then there's another band on the end which is brown. So looking at that, we can look at our resistor chart, and it's brown, which is a 1, green, which is a 5, black, which is a 0, times a multiplier of black, which is 1, and then a tolerance of brown, which is 1%. And what that gives us is brown, green, black, black, brown, so 150 times a multiplier of 1 ohm, so 150 ohms with a tolerance of 1%, meaning that it's plus or minus 1%. All right, so I'm going to need to put that in line with my LED. So the way I'm going to do this is I'm going to put one leg of my resistor in row number, for me it's 29, column 29, and then the other leg is going to, so I've got one of those legs there in the same column as the anode of my LED, and then I've got the other leg placed over here, and for me it's in row 29. It's a little hard to see, but it's in row 29. So then what I'll do is I'll take one of my connector wires, and I'll grab a green one here, and now I will connect that over to pin 0. So my very first pin, pin 0. So I've got 3.3 volts coming over into my resistor. Then I've got my resistor connected to my anode. The cathode connected to ground, and I need to connect my ground rail, and it can be anywhere, over to my ground pin, which is the third pin on my microcontroller. So you can see I've got the ground going from the third pin over to the rail, and it can be any of those pins on the rail. Okay, now I'm going to come into my code, and I'm going to change my pin to be pin 0. And I'm going to run my script. And when I do that, you can see my LED comes on. Coming into my code, I can change that from an on to an off. Click run my code, and it turns off my LED. And just like that, we are able to save code to our device. So now my code is saved. All right. You can see that the save is grayed out up here. So watch this. If I unplug my microcontroller and plug it back in, because I named the file main.py, it's always going to run that code no matter what. When I connect it back, it's going to run that code. And the only code that I have is turning my LED on. So I've successfully loaded code onto my microcontroller, so my microcontroller will always turn on pin 0, which is our red LED. All right, that's going to be it for this video. In the next video, we'll learn to do some more advanced things, and we will learn to control, hopefully, a stepper motor, or a servo motor, rather.